Hello, this is Mike at Gamefromscratch, and welcome back to another Paradox Game Engine tutorial. Today we're going to be taking a look at how to do more things programmatically. Basically, up till now we've covered creating and using scripts. We've covered creating scenes inside of the Paradox studio, but we haven't really looked at how the two tie together. So specifically, we're going to look at how to access an entity created in Studio in a script, and we're also going to look at creating entities entirely in script without Paradox Studio being involved at all. Should be a pretty interesting process. Let me just fire up Paradox Studio and we will get started. Alright, so let's get check for a new version. There isn't any because I just updated yesterday. And let's fire it up. Now I may have actually encountered a new bug with this updated version, which is sort of unfortunate, but I keep losing keyboard focus on occasion. I'm not sure if it's my computer, if it's Paradox or what, but hopefully I won't run into that during this video. And we'll just fire up a new project here. Mine is going to be called, let's see, new project, new game. What's a good name for this? Scene from code. It's a horrible name, but we'll go with it anyways. And selected run. We'll just do Windows platform, keep this nice and simple, keep the defaults. And here we go. Now once again, with this tutorial, I'm going to assume that you've seen all the other tutorials, or at least understand all of the information covered in the previous tutorial. So if you don't understand something I do, there's a pretty good chance that I covered it in a previous tutorial. So in that case, I would highly recommend you hop back, jump into that, and then catch back up if I lose you somewhere. If you do that and come on back and it still doesn't make sense, let me know and I will address it in the tutorial. And once again, like all of the tutorials in this series, there's actually a text-based version of this at Gamefromscratch.com. So if you want to be able to copy the source code or you missed something in the video, just be sure to check out Gamefromscratch.com and there's a text version there. Alright, so here we go, default scene. We're going to play with the default scene once again. And let me just go ahead and run this once. Let me make sure that I'm on performance here. I am. Alright, so let that build. It should run. I hopefully don't have the speed problems I did in the last Paradox video. And let's see. I'll just pause. Oh no, it's done. Okay, so here we go. Our first run, and there's our scene. Default scene with the ball. We've seen it many times already. Same thing once again. So now what we're going to do, we're going to do a couple things. First, we're going to go ahead and actually create a script that we're going to use as our test. And then what we're going to do is get a reference to that sphere from Paradox Studio, this guy right here, in code, and then attach our script to it programmatically. Instead of going in here and adding component and adding a script type, we're going to do this completely in code so you can see how that integration works. But first, we're going to need a script to actually attach. So go ahead, add it into your game, add a new class. And I'm going to call this back and forth for reasons that will make sense in but a moment. So don't need any of this. Here, let me just zoom this up so you can see. We need system, maybe. I assume you need system. And silicon studio.paradox.engine. Okay. So once again, make sure that your class is public so that the editor, etc. can see it. And we're going to use a synchronous script this time because they are easy. And I will let it fill in for me. Alright, perfect. So this is our update. And we're going to need a couple of member variables here. Private, they're not being shared anywhere. So current x equals 0. Private const float max x equals 5. So this is our current position along the x-axis, and this is going to be the maximum amount will go in one direction or the other. And finally, bool go right is false. It's kind of a bad name, actually. It's a bool of basically which direction we're currently going. So now let's implement our script. Again, we've covered all of this in the scripting version. I think that was 2 tutorials ago, so if you need a brush up on what we're doing, just head on back there. Is running, and if go right, and here, let me just block this in so that we're started. Alright, else go left. And our logic is extremely simple. If we are going right, current x plus equals 0.1f. So very simple example. I'm not taking into account the different speeds different computers run at. There's no normalization going on here at all. It's just so that we have an example to work with. All right, so either go left or go right along the x-axis. And finally, we just check to see that if we are beyond plus or minus 5, so our plus or minus our max. So math.absolute current x. So basically that's just removing the sign, like so. And if this is the case, we'll flip our directions, like so. So basically, if we go past 5 and we're going right, then go left. If we've gone past -5, then go right. It's the simple logic in this guy. And then finally, update our position. So entity.transform.position.x equals current x. Very simple script. Hopefully it works. That's always nice. Let's do a build here. We'll click here so make sure it gets updated in the editor, which we shouldn't need, but now the editor should at least be aware of that script. Okay, so succeeded. So we now have a script to work with. Let's now look at adding that script to our entity using code. Now, in order to do this, we're going to have some code to run, and we don't have any yet. And up till now, in the previous example, in the last chapter, I actually showed you how to extend the game class. And that's a perfectly valid place. If you want to do configuration code to set up all of your various game objects, like we're about to, so we're attaching a component to an entity using code. This is the kind of thing that totally makes sense to put in your game in the initialize type logic. However, in this case, we're actually going to use a startup script. I mentioned them briefly in the last tutorial, so now I'm going to actually go ahead and use an example. A startup script is simply, it's a similar script to your synchronous and asynchronous script, but instead it doesn't have an update method. So this is basically a script that is called when your scene starts up. And they're very, very simple to work with. But first we need to add it to something in our scene. Oh, actually we're going to need one anyway. So let's go ahead and create our startup script first, and then we'll go and add it to something in the scene in a second. So first things first, let's create a very, very simple startup script. So that is again in your game class, not in your platform specific class. And we'll just go in here and we'll add a new class like so. I called this incredibly brilliant startup. Make sure class is selected. Like I have it, nope, like so. And all right, we are going to need link. We are going to need collections ultimately. I don't think we'll need thread. So using Silicon Studio dot paradox dot engine, and I'm foreshadowing a bit, but we're also going to need the rendering class for the model way down the road. You can add this later on if you wish, but this is ultimately something we're going to need. And then finally, we need to inherit our class from startup script. So instead of async script and sync script, we also have startup script. There's also technically script, but that's more of a base class. You wouldn't want to use that. So now that we've got that, we've got to override the start method. There we go. Hello start. There. Yeah, and you know what? This is good. This is our base class. We'll go with this for now. Once again, and I always forget this, make sure that your class is public so the editor can see it. And we'll do a compile, make sure everything works. Modified, so the editor should be able to see it. So here we go. So now what we need to do is attach that startup script to something. Theoretically, we could attach it to anything here, but that's kind of clunky. So we're going to go into our scene, our root of our scene, and we'll do an add new empty editor, or I guess create, and a new empty entity. Ugh, that's hard to say. We'll name this guy config, like so. I don't care about grouping, and we'll go ahead and add a script to it. Add our script, startup. Okay, perfect. So now when our game runs, it will create this config object, which is completely empty. You can position it wherever the hell you want, because all entities have a transform component. So even if it doesn't need to be positioned in space, it can be. But it's not visible, it's not rendered, so it doesn't really matter where you put it. But it does have our startup script attached. So as soon as that entity is created, that script will run. And that script is what's going to configure the script attached to this guy. Okay, so we should be good to go. Let me just go ahead and do a run just to make sure that everything is in order right now. And I shall head back over here. Now we're going to do the entirety of our work right now is going to be in this guy. We're going to run entirely from this startup script for the rest of this example, but we're going to keep coming back to it. I'm going to keep adding new feature and functionality one by one. All right, now the very first thing we're going to want to be able to do is find an entity in our game world somewhere. So we're going to basically be able to find that sphere somehow. And that somehow is actually using something called link. Now, entity is part of the scene, and it's simply a collection of entities within the scene. It's a very straightforward way of doing things. But first we need to pull our scene. And what that means is, remember before I showed you when you created multiple scenes and, oops, let's actually don't even need this guy, get rid of it. You created multiple scenes, they tabbed across here. You can have a collection of scenes making up your game. So you need to be able to figure out which scene is current. And that is done with a function called the scene system is where it contains the scenes. Scene instance contains the running scene. And we're going to query it for our sphere. So, by the way, here's our sphere right here that we're using. You notice its URL is sphere and its type is procedural model. Now what we're going to do over here is go var sphere, like so. And now we're going to use a link query to check for it. Actually, this first query is to show you more of a broad sweeping example. We're going to check for all entities within the scene that have a model component. That is, so you see this guy, the sphere, and come on, no, sorry, over here, sphere as an entity, not as a model, but as an entity. This sphere right here has a model component attached to it. And so what we're going to do is query the scene for all model components. We're going to start with that, and then I'm going to show you how to query directly by name. But this is showing you how you can select many items in your scene using code. If you've got no experience with link, I haven't used it for a while, so my link is probably going to be somewhat terrible. But link is a querying language built in C# on top of the generic stuff that they've built in. Very powerful stuff. And it works a lot like SQL queries. If you've used SQL in the past, and it allows you to poll basically any single IEnumerable or higher level data structure. Very, very powerful stuff. So from entities in this .scene system .scene instance, so that's what I was talking about. That is the current scene, and the current scene is simply a collection of entities that compose it. So there's not a lot of magic there. Now we put our criteria in where entities, so let's spell that right. I didn't spell it right the first time. All right, let's fix that. Where entities dot components, so all entities have a components container, even if it's empty. And then we're going to check contains key and model component dot key. So basically we're saying anything that has inside of its components collection the key of type model component, we want basically to select it. So select entities, like so. And now you notice I've been wrapping this entirely in brace brackets. That's because we're going to take the result. This result's going to be basically, I think it's an IEnumerable. We just want to basically take the first value. And that's a method called first or default. This is either going to return the first value returned by this query or null. So all right, very simple. So basically, we're querying the current scenes list of entities to see if any of the components contain the key of type model component. And if they are, we want the first result. Since there's only one thing that actually fits this criteria, which is our sphere, we can safely get away with this. Unless there's an error, in which case this will throw up. And let's just go ahead and set a breakpoint, and I will show you how this works. Go ahead and run that. Da-da-da-dum. Da-da-dum. Da-da-da-dum. And boom, we've run. Let me mouse over, see what sphere's value is. And there you see, it is an entity named sphere. Perfect. And you can see here the components that compose it, the model component, and the transform component that all entities contain. So there you go. We just pulled the scene. If we had multiple spheres or multiple entities with model components, this would have returned a collection of them, which we could iterate through. So this is sort of an overkill way of getting the sphere value out, but I wanted to show you how this querying works. Now let's go ahead and just get it by name. A much clearer, probably more realistic way of doing this. First, let's shut this down, and we will comment that guy out, and instead go with var sphere equals, very similar, AU. From, why are you doing this? Entities in this .scene system .scene instance, where entities.name equals sphere, select entities. And really that's it. And then we'll use the same logic. I don't know why IntelliSense is angry at me here. Oh, why did you... Ugh. Sometimes IntelliSense pisses me off. Alright, so basically the same result. This is instead polling for it by the entity name. And if you come back here, you'll notice every one of these entities. So we're on the ground entity right now. It has... Oh, actually, look, ground is a model. So that list would have actually returned ground as well. So we got sphere first because of its order in the scene graph. So when we did the entire collection, as that initial result returned multiples. So anyways, you'll notice here in sphere, the entity's name is sphere. Here in ground, the entity's name is ground. Actually, this value is being set by that value. So if I keep going through this list, it's going to match again and again and again. So here we are just querying our entity by its name. And there you go. So that is a way that you can get a reference to things that exist within your scene. Quite simple. If you don't know Link, way beyond my capacity to teach you right now. There's a lot of great resources, especially in MSDN, where you can learn a bit more about Link. Most of your queries will ultimately end up looking a whole lot like this. You can get into some very, very complex stuff, but well beyond what we need here. Also keep in mind, entities can be nested underneath other entities, so you may have to actually pull down the scene a little bit further. Which again, a link query can handle that logic as well. So there you go. We now have a reference to our scene. What shall we do next? Yes. So now we're going to go ahead and attach that script we created, this back and forth script. And it is attached as a component. Specifically, a script component, like this guy. Sorry, I cut my fingertips, so I'm a lousy typer right now. So create a new script component, like so. And remember, a script component, as we saw over here when we attached it to our config file, the script component is actually a list of scripts. So important to remember that. Because what we need to now do is attach or add a new script to our scripts list. And it is of type new back and forth, like so. And then we simply add that component to the sphere. Sphere.components.add. Give it a type. So it's of type script component, like so. And so it works with keys all the time. So script component.key, statically defined for you, and then pass in your new script component. IntelliSense, you're not being very intelligent. Script component, like so. So now we have attached this script that we created earlier to our sphere component that we pulled from the scene. And that, in theory, should work. And there you go. So now our ball, our sphere in the scene, now has the script component that is running for this back and forth. And that is programmatically adding a component to, well, pulling an entity and adding a component to it. Now let's actually look at creating a new entity. Their system is actually quite clean. The nice thing is an entity is basically just a component container. That's it. So creating a new one is actually quite straightforward. And if you can type entity equals new entity, and we're going to give it a little bit of information straight off. Now remember, every entity has a position component off the hop, and we'll go ahead and set the position during initialization. It's a new vector 3, yeah. And I'm just going to set it slightly off the axis so we can see both these entities, because we're actually going to use the same model for both of them. And name is my entity. So this name value is the equivalent of this guy right here. Okay, so that is added that entity in. Let's close this constructor off like so. And now let's make one of these entities happen. We're just going to use the same sphere model, this procedural model available right here. Now keep in mind it's procedural and it's not loaded from files. So we can't load it like you would normally. So instead what we're going to do, and I will show you loading an asset in a little bit, but so instead we're going to get a reference to it from the asset manager. And that is a matter of var model equals, and we're going to need to do a cast. Model. Now, keep in mind, I defined this guy earlier, and this is the namespace that contains this model. So the full namespace is Silicon Studio Paradox rendering.model. So model, and we are now doing asset.get. You pass in the type, so it is of type model. And we want the one with the URL sphere. So again, from our assets, hover over, you can see the URL there is sphere. So that gets a reference to it from our scene, nicely enough. And now we'll go ahead and create a component using that reference. So model component. I'm very original with my names today. Model component equals new model. IntelliSense, you're failing me hard here. Like so. So we're basically just creating a new component with that model as the parameter. And finally, entity.add model component. So we're adding the component type like we did earlier with the script of type model component instead. And once again, you need the key of the type. And of course, you need the component. Like so. And then finally, we need to add this new entity to the scene. So scene system dot scene instance dot scene dot add child. Now scene is the collection of entities in the scene. So we need to add a new one to it, like so. So quick recap: create our entity. I have a bit of an error here. Let's see. Position new open close comma. One too many of these. All right. So create our new entity, passing in its location and its name. Both were optional, by the way. Create a new model, or get a reference to the model from the asset manager. This is defined for you, but this is ultimately of type asset manager, and it'll get the type of by the URL you specify. We then create a new model component using that model type we just loaded. We then create an entity component of type model component using our newly created model component variable, and then finally add it to the scene with a call to add child. And in theory, when I run this, we shall now have two spheres. There you go. Now remember, I moved one slightly along the z-axis, I think it was z-axis, so that we can see them. They're separate. Another thing you should notice here is one is moving and one is not. That's because we just used the physical model. The script is actually attached to the other entity. Now this does lead into an interesting thing, because we could have also created this new guy, another sphere in the scene, by a method called cloning. And in this case, we would inherit everything. Now, another thing we do need to keep in mind here is this model here and the one in that first entity are identical. So they're actually the same entity, we just got two references to it. So if I change this model, it changes on both. And I'll show you exactly what I mean by doing that. We're going to go ahead and create a new material in our scene. You can create a material in code too. But truth of the matter is the process is a gigantic pain in the butt. So I'm just going to use the editor for this. This is the kind of thing that you use the editor for, but if you wanted to, you could do this entirely in code too. It's just very complicated. So I'll create this new material. We shall hit F2 to rename it, and we shall call this guy my material. Now let's just set this diffuse map to blue. That's it. That's the only difference between our two materials. One is yellow, the other is blue. You can set all of the rest of this stuff for it. Not going to. Good enough for me. So let's save it so that it's available. And now we head on back over here. Now let's go ahead and change the material for our, well, we'll do it on our new entity, but it's going to be kind of moot because, as I said earlier, it's going to affect everything. So first we're going to need a reference to that material. So var material equals asset dot, and this is a streamable material unlike the dynamic one from before. So we can go ahead and use load from the asset manager instead of get that we used before. And we're going to pass in the type we want, which is a material. Sorry, not pass in, but template. And give the name that we want, like so. And the asset manager will load that guy for us and into our material class, like so. So now let's take our model. Keep in mind, it's the model component. Well, actually, it's the model, not the model component that has a material attached to it. So your entity contains the model component contains the model, and the model itself contains the material. Clear as mud, right? So first things first, and I don't know if this is strictly required or not, but I'm just going to go ahead and do it. So I'm going to purge all of the materials that are currently attached to that model. And then model.materials.add new material instance, like so. And we pass in our material that we loaded a second ago. And I think that's it, actually. So now, instead of yellow, we shall see blue. There you go. So as I said, you're actually affecting all of that model. If you wanted to have it independently materialed model, you would actually have to create a new model that would be used here. You could clone it and make it otherwise, but you would have to create a completely new instance. So we're affecting all instances of the model, not necessarily the entity. Hopefully that made sense as I was yawning and trying not to burp. Okay, so that is changing the materials on an entity that we created from scratch using code. Now let's look at a much simpler way of creating a new entity. So we'll make one more sphere in our scene, just so we have this super fun sphere. And this is also going to show something different. Is remember how this new entity that we created that reused the model of the first one did not have that script attached? It's because they are different entities completely. So the second entity that we created did not have that script attached to it. We could have attached it the same we did the first time, and we could actually reuse this completely. We could just attach this particular script component to our other entity as well. But what we can also get away with for creating a new model is, so if you want many instances, identical instances of the same entity, very simple to do. So what we're going to do is go another sphere equals sphere AU dot clone. There you go. Then you got another one. And it's that simple. So finally, we're going to want to position this guy slightly off. So transform.position.z equals 1f. And finally, we need to... Oops. Well, basically we need to do this. So there is a much simpler way of creating additional instances of an entity. So this is a copy though, keep in mind. So it will from this point on be a different guy, but it still has the same references to the same component. So when we made this one component's model blue, it's ultimately going to trickle down to all three entities in our scene now. And in order to get around that, you would have to create a completely separate instance of your asset. But there you go. So now you've seen three entities in the scene, all created in a different manner. And frankly, that's about it. So quick recap of what we covered here in code. First off, we created a new script called back and forth, a typical sync script, and all it did is moved our entity back and forth along the x-axis. Nothing special. But then what we went ahead and did is created this startup script. And remember, the startup script was attached to an entity. We created an empty entity called config that we in turn added a scripts component to. Again, you could have done it like we did in the last tutorial, created your own game class and did the same functionality in the startup logic of your game class. But this works too. So once we created that startup script, we linked it here as a component. And let's go back to our startup script quickly. So in our startup script, we showed you two ways to access the scene. This first one is basically says, give me all the entities in the scene that contain a model component. Bit of overkill, especially because we only wanted the one, but if you were doing a bulk query, you could use this for give me all entities of type that contain a light or that are a camera, etc. But then we also showed you how you could do it using the naming value. So simple entities.name. Again, this is using something called link, part of C#, way beyond what I'm going to teach here, but if you don't know link already, go learn it. Very powerful stuff, nice stuff, great way to deal with data. Quick check to see if our result returned nothing, because otherwise we're going to blow up when we try to add things to it. And our first bit of logic then is we created a script component in code for our back and forth script, added that component to our sphere component as a script component. So our sphere entity components collection, we added a script component type. Again, you use the key and then the value you want to add. And then we went ahead and showed you how to create a brand new entity from code. In this version, I decided to give it a position value and a name right on the constructor, but you could have just created a new entity, define those later if you wished, or not at all, which would be a mistake. Then we attached, we got a reference to the model, the procedural model from the Paradox Studio using the asset manager, which again is made available for you already, which is handy. And then we created a new model component using that model, and then finally added that model component to our newly created entity. Then I also showed how you can load a material from, again, that was created in Paradox Studio and assign that material to a model. Remember, the model is part of the model component, which is attached to the entity. I also showed you how you can create a new instance of an entity via clone. This will create a new copy. Now, they have shared references to the same base components, but they are distinct versions. Positioned it elsewhere. So as you saw, when I updated the position here, the original... Same end result is one moved and one didn't. I just moved the wrong one, which could have been a little confusing. But as you saw, when I actually made that transform change, it obviously only applied to one of the entities. So clone is a distinct version with its own values. And then you just finally add your entities to the scene using the add child of scene instance. And scene instance is the currently running scene, which is made available by the scene system, which is available everywhere. Okay, so that is it. Hopefully that filled in the link between coding and your scene. It shows you how you can do pretty much everything programmatic. Now, some of it, like I said, creating a new material from scratch completely in code is a pain in the butt. There's a lot more to it. It's not as nice of a direct one-to-one map between code and what you're doing, but you can. Everything you did in the studio, you can create in code, and almost vice versa. So hopefully this cleared up a little bit of what's happening between the two. That was it for now. Thank you very much. Goodbye.